my multi-rotor setup presentation. Oh, sorry. Okay. We'll be going over today is how to prepare the multi-rotor for setup, how to like the calibration of the sensors, how to check the remote control transmitter, the calibration of the electric speed controller, the motor check, and the stabilization and control check. Okay. To prepare the multi-rotor for setup, it is important to do a pre-flight inspection beforehand and check that the drone is in good condition. Check for short circuits using a multimeter. You don't want that to catch fire. And make sure the correct software is installed. Also make sure there's no debris or anything kind of like stuck in the gear, like the propellers and the motors. Then remove all the propellers, power on the remote control and the drone, and connect the receiver to the transmitter. Then install firmware on the flight controller, and that's on the drone. Check the drone's connection via the telemetry link, and the telemetry is the data gathered around the drone, and that data is sent back to the controller. That's kind of important. Okay, to calibrate the sensors, there's the internal measurement unit, so the IMU. That's used to measure the altitude, speed, attitude, speed, and altitude of the drone. Most softwares require the operator to know where the sensor is on the drone. After this is done, then the IMU can be calibrated, which makes sense because you don't want it to be off because the sensor's in like the wrong place or something. The compass is important because that tells the drone where the magnetic field's in the area and where it is within itself. And that can be calibrated by holding the drone while turning 360 degrees, and you repeat this action while holding the drone in different ways. The power management unit, the PMU, regulates the power going to the flight controller, ESC, and other components. To do this correctly, enter the correct battery voltage using the battery cell checker. So those are all like important sensors. Okay, and then to check the RC transmitter. So this is just making sure the RC controls to the drone do like the right movement or have the right feedback. So I made this little like chart, and there's a picture. So you want it to be able to like, here's an example, like the picture, the roll, left, right, pitch, up and down, throttle, up and down, and then yaw, left and right. And then there's like little trim, like you can't see because the airs are over, but you can like trim it out too. But you just want to make sure that's right. And you can also change the inputs. Like for example, if you're left-handed or something, you might want to switch it around, whatever works best. So you just need to like kind of like find what works for you or what you want. Make sure that's all set up. Okay. To calibrate the ESC, it's the all-at-once calibration because there's 4 electronic speed controllers, so you kind of do them all at the same time. Okay. To prepare the motors, connect the motors to the ESC and connect the ESC to the PDB. Make sure the airframe is assembled correctly and make sure everything is attached appropriately. You want the motor secure and the propellers are not attached, so you don't want those on. You also have to check if they're free of debris and can spin freely. And then you turn on the remote control and make sure it's configured to have the flight controller in all-at-once calibration mode, so you can get all 4 ESCs done. Then the ESC in calibration mode, and move the throttle into the maximum power. The ESC calibration mode will be then verified, and then move the throttle into minimum power. So you kind of move it between maximum, minimum, and then the ESC will beep when the calibration is complete. So that's kind of a rundown. And this is what like an ESC looks like. Okay. To test the motors, you can test them one by one. This will make sure that each motor is connected to each port correctly and check if each motor is spinning in the right direction. To switch directions, swap 2 connectors between the ESC and the motor. And then you can kind of see like right here that these are the motors. Okay. stabilization, and control check. The purpose of this check is to verify that the motors respond to the remote control and make sure that the drone can stabilize itself based on the motor's responses. So there's kind of three types. There's with the propellers off software check. The check the signal being sent to each outports on the flight control. This check will not check the motor or malfunction and calibration errors. So this is kind of on the remote control. You kind of check this digitally. There's not too much you physically do for this one. Kind of just look at I don't know the stuff. Oh, go back. Okay. With propellers on hand check, hold the drone while avoiding the propellers, and then another person's gonna put in 50 power on the remote control, and then put in pitch and roll inputs. And while they do this, they're gonna tell the person what inputs they're putting in, and then the person holding the drone should be able to feel the drone moving in the correct axis. And then you can manually move the drone around, and the motor's thrust should correct this action. So you're checking if it can stabilize itself. This check is done with smaller drones that you can hold, but if you have a bigger drone where you can't really hold it, then there's the strap down check. This is the propellers where this is the propeller on hand check, but the drone is strapped down to the table. You're still checking, you're still moving the 50 power, you saw that, and then moving the axes, whatever. And then you should be able to see a small flex in the arm to tell that it's moving. But this method does not check stabilization because it's trapped to a table. So yeah, and then my resources. I just use the drone manual, pretty straightforward. It's great. Yeah. Okay, thank you for watching my presentation.